All right, beautiful people, today we're going to be learning about 9.4. Our SWABAT is solve polynomial equations in factored form. We'll talk a little bit more about factored form later on, like next week, but for now, I want you to know about the zero product property. It says let A and B be real numbers. If A times B equals 0, then either A is equal to 0 or B equals 0. A times B. So if I'm telling you two numbers, when you multiply them, you get 0. Then that means that one or both of them would have to be 0. Make a little bit even more sense once we get to some examples. The next thing I want you to know is factoring. To solve polynomial equations using the zero product property, you may need to factor out the you may need to factor the polynomial or write it as a product of other polynomials. For us and for today, we're only going to be looking for the greatest common factor, the GCF of the polynomials, and then we'll factor that out. And for today, it's going to be a monomial. We're only going to be able to factor out one term from both of the terms, or from all of the terms that are in our polynomial. Let's take a look at that in just a bit. So our first set of instructions is just to solve. So we're going to solve this using the zero product property, which, as you may remember from our previous little thing here, A times B equals 0. So either A equals 0 or B equals 0. So for us, all we'll need to do is set each of these 2x plus 1 equals 0 or x plus 4 equals 0. From here, you're going to apply what you learned in chapter 3 about solving. So I'm going to subtract 1 and subtract 1. Then I get 2x equals negative 1. Then I'll divide by 2. And I have x is equal to negative 1/2. That's one answer. That's like the A part of it. The B part of it is to now do the same thing with the other equation that we just created. And when I subtract 4 from both sides, I get x equals negative 4. So on an answer column, you would say x is equal to negative 1/2 or negative 4. And that would be your final answer. Same concept for part B. You have two things that are being multiplied here. So instead of multiplying them out, I'm going to set them each equal to 0. So x plus 7 equals 0. 3x plus 6 is equal to 0. And solve. So minus 7 and minus 7. X is equal to negative 7 for 1. I'll subtract 6 on both sides and get 3x is equal to negative 6. Divide by 3. Divide by 3. X is equal to negative 2. So my final answer would be negative 7 and negative 2. That's using the zero product property. We're going to love this section just because today these are already in factored form. Next week, we'll learn how to factor them ourselves. Next part, the other side of your sheet of paper, if you flip that over, says factor out the greatest common monomial. Monomial, remember from earlier this chapter, is a polynomial with only one term. So there's one term I'm going to factor out of both of these. So I'm looking at 6x squared plus 10x. And I'm always going to look at the numbers first. So I'm looking at 6 and 10. And then I would ask myself, okay, well, what number goes into 6 and 10? What can you divide both of these by? I can divide both of these by 2, because 2 goes into there 3 times, 2 goes into 10 5 times. Now you're looking at the x terms. This is x squared and x. How many x's can you take out of both of them? Just one, x to the first power. The only thing is, though, we don't put the 1 there because it looks like we don't know what we're doing. So we would just write x. This had 2 x's, this had 1, so I'm taking out just an x. Now your leftovers will go into parentheses. So if I took off 2 from 6, I still have 3 left over here. And then x times what gives me x squared? X. How do I know I'm right? Well, what's 2 times 3? 6. X times x, x squared. Plus, how many times is 2x going to 10x? Well, let's look at the numbers. 2 goes into 10 5 times. X goes into x 1 time, but we don't need to put the 1 here. How do I know if I'm right? I can check it. What's 2x times 5? 10. So that's good. We have now factored out the greatest common monomial. If you're kind of confused about this x part, I'll tell you the secret for this in just a moment. Looking at the next one, I'm always going to look at the numbers first, the coefficients. So what goes into 8, 10, and 18? 8, 10, and 18. 2. Now you're looking at the variables, a squared, a cubed, and a to the fifth, a cubed, and a squared. They all have a's in common, but the maximum I can take out, if this has 5, 3, and 2, the max I can take out of all three terms would be 2. Now your shortcut here is whatever the smallest exponent is, which for us is a squared, that's what you're going to take out. And then you're just going to deal with your leftovers. Just like for here, the x is smaller, so that's what I took out from both of those terms. So leftover, 2 times what gives me 8? 2 times 4. And now 8 squared times a to what power gives me a to the fifth? Well, if I had 5 and I took off 2, a cubed. So this is a total of 1, 2, 3, 4, 5, which is what I needed it to be here. This is minus, so minus 2 times what gives me 10? 2 times 5. Now I had 3, a cubed, and I took off 2 of them, so I still have just an a left. This is like a to the first power, 1, 2, 3. This is my third, so that works out well. However, you already know, we don't like that one there. It does not look good for us. So I would erase it if my eraser was working. There it goes. Plus 2 times what gives me 18? 2 times 9. And I took out a squared, so there's none left there. So that's it for that. If you would like to, and you're feeling pretty good about this, you can go ahead and press pause and then try C and D. If you're feeling a little bit shaky, you can walk with me through this and not fast forward through in a little bit. So the common factor for 5, 25, and 10, 5 goes into all three of those numbers. And then my lowest exponent is just a c to the first power, but we're not going to write that. Now what's left? 5 times what gives me 5? Well, 1, but we won't write the 1 usually. And then c times what gives me c cubed? Well, if you had 3 and you took 1 off, you just have c squared left over. Minus 5 times what gives me 25? 5 times 5. And I had c squared, and I'm taking off a c, so it's just going to be 5c. 5 times what gives me 10? This is a positive 2. Now there's no more c's left over there. One thing I would like to do just to edit, can't have a 1 here, can't have a 1 there. So now I can finally just put my box, and then we're good. Last one. 4, 1, and 3. What goes into 4, 1, and 3? Nothing other than 1, so no one really cares. But d to the fourth, d cubed, and d squared, they all have d to the second power in common. Leftovers. So what times d squared gives me 4? Well, this will be 4. And then if I had 4 d's here, d to the fourth power, and I took off 2, I still have d squared left. Plus, this is a 1, so no one really cares. And then I had 3 d cubed, and I took off 2, so I just have d left over. Minus 3, no more d's. So that's about it. And there you have it. One more. Let's go to our last slide here. Solve the equation 8b squared plus 9b equals 0. So in order to solve this, before you try to get any variables by themselves, we're going to go for the zero product property, except we don't have a product yet. So I'm going to look at these two terms here, and I'm going to factor. The number that goes into 3 and 9 is 3. And then I have b squared, and I have just a b here. So if this is just a b, I'm going to write just a b right there. My leftovers. 3b times what gives me 3b squared? Well, the 3 is gone. It's all out there. There's nothing left from that. But b times b squared, b times b gives me b squared. Plus 3 times what gives me 9? 3. And then b times, well, there's nothing left here because I took all the b's off, equals 0. Now I have a product. Now that I have a product, I can use the product property. 3b equals 0. b plus 3 equals 0. These are equations most people like because they're not super complicated. You're going to divide by 3 and get b is equal to 0. Here you'll subtract 3 and get b is equal to negative 3. Those are your two answers. Ooh, that's horrible. Two answers for this problem. Okay, letter B, if you look at it, it does look just a little bit different from part A. And if you're noticing, then you might see that it's not equal to 0, but we need it to. So this is the highest exponent. I'm going to move this to join it over there. And I'm going to do that by subtracting 28k minus 28k. And I have 14k squared minus 28k is equal to 0. Now you'll factor the same way that we've been factoring. Now you're going to look at this and you're going to say, oh great, it's going to be 7k. And you would be right, but that is not the greatest common factor. The greatest common factor would be 14k, because 14 goes into both of these numbers, here and here. 14 goes into 14 one whole time, but you don't need the 1. K, if we had k squared and you took off 1k, you still have a k left. Minus 14 goes into 28 2 times. And the k that was here is now out there, so this equals 0. So now you have 14k is equal to 0, and k minus 2 is equal to 0. These are kind of nice because you can really do them in your head. For this one, 14 times what gives you 0? 14 times 0. For this one, what minus 2 gives you 0? 2. 2 minus 2 equals 0, so k would have to be 2 for the second equation. Last one. Negative 12x squared minus 3x. So it equals 0 already, so that's great. The next thing I'm going to do is look at both of these numbers, negative 12 and negative 3. Well, if your leading coefficient is negative, you're going to take out a negative number. What goes into 12 and 3? 3. And then you can take out, looks like an x from both of these, and your leftovers would be 4x minus 1 equals 0. So you have negative 3x equals 0, and 4x minus 1 is equal to 0. If you divide both sides by negative 3 here, you have x is equal to 0. Here you're going to have to add 1. You have 2 steps to do for this one. So you get 4x equals 1, divide by 4, and x is equal to 1/4. So I would write x equals 0 and 1/4. This one. Don't put this in parentheses though, because it's not a coordinate. Okay, one slight change from your homework assignment sheet, beautiful people, because you should have a lot of time left over today. Instead of just doing assignment number 4, that's the 5 through 13 odd, you're going to add homework number 5 as well to that. It says it's for Monday, but go ahead and do it tonight because you'll get a nice little head start on that. So do assignment number 4 and assignment number 5 before you leave today. Thank you so much and have a good day. Bye-bye.